This function is called reciprocal of x squared. Also sometimes called rational squared. The equation for this function is f of x is equal to 1 over x squared. So very literally it's saying the reciprocal of x squared. To figure out what this graph looks like, I'm going to pick some x values. So I'm going to start with -1, 0, 1, and 2. And if we need more, we'll add more. If I put in -1 in place of x, then this would say the y is equal to 1 divided by -1 squared. So -1 squared is 1, so that would be 1 divided by 1, which is 1. If I put in 0 in place of x, then this would say y is equal to 1 over 0 squared. Now 0 squared is 0, and 1 divided by 0 is undefined. If I put in 1 in place of x, then this would say y equals 1 over 1 squared. 1 squared is 1, 1 divided by 1 is 1. If I put in 2, this would say y is equal to 1 over 2 squared. 2 squared is 4, so that would be 1 over 4, which is 1/4. I'll go ahead and plot these points and see if I can see a pattern. The first one, -1, 1, start at the origin, go to the left 1 and up 1. At 0, it's undefined, so that means when x is 0, so all here on the y-axis, I'm not going to be able to draw a point at all. 1, 1, so we'll start at the origin, go to the right 1 and up 1. And then 2, 1/4, so I start at the origin, I go to the right 2, and then up 1/4. Now we saw in the reciprocal of x video that when we had an undefined, the graph kind of went really high or really low as we got closer to that line, wherever that vertical asymptote was. This one I can also kind of generalize from the pattern that I've got here. It looks like there's probably going to be a horizontal asymptote as well. Just to check it out, I'm going to pick 1/2 for my x value. So if I put that in here, it would say 1 over 1/2 squared. 1/2 squared is 1/4, and 1 over 1/4, well, that's 1 divided by 1/4, which would be the same as 1 times the reciprocal of 1/4. So it would be 4. So that means that 1/2, 4. So if I plot that, start at 0, 0, the origin, go to the right 1/2, and then up 4. So it does look like as I get closer to an x value of 0, it looks like the graph is getting large very quickly. Just to be sure also this direction, if I pick an x value that's larger than 2, like say 3, and I put it in place of the x here, it would say that the y is equal to 1 over 3 squared. And 3 squared is 9, so 1 over 9, 1/9 would be a very small number, but still larger than 0. So this is going to go up very quickly as we get close to the y-axis. And it's going to continue decreasing over here, getting closer to 0 as we go off to the right. Now because the x's are always squared, that means when I put in negative x values, I'm actually going to get the same y values. So the left side of this graph is just going to be a reflection of this one across that y-axis. Now there are 2 asymptotes on this one also. The asymptotes, as a reminder, are at boundary lines. The graph gets close to them as the numbers get the values of the independent variable get closer to the extremes. So there's one here at the y-axis. The equation of that asymptote is x equals 0. And there's also an asymptote, a horizontal asymptote here at the x-axis. The equation of that one is y equals 0. The domain of this function, we can put in any x we want to except for 0. So if we put in a 0, we end up with something where we have to divide by 0, which is undefined. So we would say x can be any real number. So x belongs to the set of reals, and then a comma, but x does not equal 0. For the range, the y values on this one are always going to be positive since the x is squared within the equation. Any number that you square other than 0 is a positive number, and 0 can't be put in place of x, so that means they all have to be greater than 0. So I'd say y is greater than 0. That's strictly greater than, not equal to. Intervals of increasing, decreasing, and constant. As I move on my graph from left to right, starting as far left as I can see, my pen is actually going up a little bit, very slowly, until I get pretty close to 0, and then it goes up really fast. But since my pen is going upward the entire time, for this interval of x's, the y values are increasing. So that would be from negative infinity to 0. I'll close that in parentheses. And I have to skip over where x is 0 because this function is undefined for an x value of 0. So I'm going to go to the other side of the function now. Put my pen on the first part that I can see, and as I move my pen to the right, in order to stay on the curve, I have to move the pen downward on the paper. And then I would continue doing that forever if I kept going. So for this interval of x's, from where x is 0 until x is positive infinity, this function is decreasing. These two intervals actually make up the entire domain. That's the same as all real numbers except for 0. So since it's increasing on one of the intervals and decreasing on the other, that means it can't ever be constant. What you need to know about this function is the name, reciprocal of x squared. The equation, f of x equals 1 over x squared. You need to know the shape of the graph and the location of the asymptotes. You need to know the domain and the range.